Great. I want to thank you very much for inviting me to come speak to you today about, yes?
Rock shop, can you?
Thank you. And I want to thank you for inviting me to speak to you about what I think is a very exciting research consortium, CReATe, that's dedicated to studying motor neuron disorders, including HSP and PLS. So CReATe is part of a broader network known as the Rare Disease Network, which I'll talk a little bit about today, but what I think is a really great example of government funding helping to support an underfunded area of research like rare diseases. So as you heard, my name's Jeff Statland. I'm a neurologist. I work at the University of Kansas Medical Center. I have specialty training in the design and conduct of clinical trials. I too, like CReATe, am a good example of where government funds have gone to help train new investigators, in particular for areas that are not as well served like rare diseases, HSP or PLS. And this started early in my career where I did a research internship at the National Institutes of Health, working with Dr. Mary Kay Floater, learning about primary lateral sclerosis. Then early in my career, I was a trainee for one of the very first consortiums that were run on this rare disease network, looking at rare channelopathies. I did my fellowship training where I learned about the design and conduct of clinical trials in a program at the University of Rochester that was also funded by the NIH and was a government-funded training program. And now, of course, I'm a member of CReATe. So the CReATe Consortium is important not only because it brings together academic institutions from across the country to study a rare disease where there may only be a few individuals at any one institution, and not just because it enables us to reach out to our international colleagues who have similar programs going on in their countries, but because it really lays a foundation and provides infrastructure for running clinical trials and for therapeutic development, which is the ultimate goal of CReATe, to develop new therapies for these disorders. And I think it's an exciting time for rare disease research and drug development. There have been 3 new drugs approved by the FDA for rare diseases in the last year in the neuromuscular area, 2 for Duchenne dystrophy and 1 for spinal muscular atrophy. And despite some of what you may have heard about the controversy related to the pricing of these drugs, I think it provides a powerful model for the pharmaceutical industry and a path forward for drug development into rare diseases. So what I want to talk to you about today is I want to talk about what is this thing, this rare disease clinical research network. I'm going to talk a little bit about the specifics of what CReATe is and what we're doing. I'm going to talk about a registry which you can all join, which is associated with the CReATe network. I'm then going to discuss 2 of our important studies that are running on this network, and I'm going to try to present a little data back to you, but it's very early in the process for us, so we don't really have full analyzed data to present today. But because I'm talking about government-run programs, I think the first thing I'm going to have to do is talk a little bit about acronyms, because there are a lot of them. So it started with this thing, the ORDR, the Office of Rare Diseases Research, who back in around 2003 identified that there was a real need for funds to help promote development of research into rare diseases. This is now part of something known as NCATS, which is the National Center for Advancing Translational Sciences. This is a well-named institute because they're really on the cutting edge of building infrastructure, the basics of regulatory oversight and how we manage data for doing cutting-edge research, and they have a particular interest in rare diseases, and the Rare Disease Clinical Research Network is funded by NCATS, and of course CReATe, the clinical research in ALS and related disorders for therapeutic development, which is much easier just to remember. CReATe is a member of the RDCRN, and all of them, every one of them, are part of our National Institutes of Health, and this is that master organization that helps distribute funds to all of these different research endeavors. So why do we need something like the RDCRN? There's about 7,000 different rare diseases, and this number changes year to year. In the United States, we define a rare disease as any disease that has less than 200,000 people. But if you take them all together, this represents about 25 million individuals in the United States. And if you go to Google, like any good researcher, and just enter rare diseases, you'll come up with something, a picture like the one I have here that says 10% of the world's population has a rare disease. And indeed, this might be true. Rare diseases are complex. They're often inherited. They often have inadequate or no treatments available. Less than 500 of these 7,000 diseases have treatments available. Therefore, they represent a large share of our healthcare spending. People who have these rare diseases frequently are misdiagnosed or will have very long diagnostic ordeals that I'll hear about before they find someone who recognizes what they have. And it's very difficult to study a disease where only a few individuals may have it at any given site, which means that we need collaborations, and many of these can be quite costly. So what's the overall mission of the Rare Disease Network? Well, it's designed to advance medical research into rare diseases by providing the support for clinical studies so we can understand them, to facilitate collaborations across institutions, and to help us with things like enrolling patients and managing the data. And from the very early days, the RDCRN used this model that all stakeholders, all the people who have a say in what goes on in the disease, should be involved in the process. This includes patients and the patient advocacy groups, the academic researchers, the government organizations who are funding it, but also the drug industry, because these are the people making the drugs and they need to be a part of the process. These studies are designed to help us get a better understanding of what happens in the disease. We call these natural history studies, and I can't emphasize enough how little funding there is out there to run studies like this to better understand these rare diseases. It helps us improve the diagnosis and develop therapies. That's all and good, but what is the RDCRN? How does it do it? Well, if you think about building a house, you have to lay a foundation and build the frame before you can construct the house. So the RDCRN provides money for collaborative studies, and it creates infrastructure. The infrastructure are coordinators. These are the people, sort of the unsung heroes of research. They do all the paperwork and help us reach out to people and do all the things we need to do. The evaluators who make measurements if you come in for research visits, the investigators. It provides actual site, a physical site for the data collection and coordination, but also people to help make sure we're collecting the same things in the same way at all these different institutes, make sure that this data is complete and of high quality. It provides a mechanism for central ethical oversight. For any of you in here who've ever been involved in clinical research, you may be aware that before we do studies, we have an independent ethical review board at each site who reviews what we're doing, and they may make changes. And you can imagine if you had 10 centers trying to get together to do research, and each of those centers was making slightly different changes to what you were going to do, it would be very hard to get a study up and running. By providing this central oversight, it greatly facilitates and streamlines the process of getting studies up and running. This network has a public interface. It's a website This is the web address here. You can just Google RDCRN and you'll get to it. There are registries that you can join to get information about the studies that are going on there. You can learn about the different diseases. The patient advocacy groups have links there. It also has a private interface where people like me go and we enter data or we download forms. Training the next generation of rare disease researchers is a major goal of this network. And they have a lot of resources that are devoted to doing this. So this is a government organization, and I've talked about institutes and networks. So of course, there is a complicated flow diagram, and you can see it here. This was their tool to help you understand what they're doing. And it's not quite as difficult as it seems. Just imagine that's an octopus. That red circle is the head. That's all the data and the central regulatory oversight that I talked about. Those colored things branching off, those are the arms. Each of those arms is a consortium studying a different set of rare diseases and made up of a bunch of centers. And you can see that there's this integration between the advocacy groups and patients and what each of these consortiums is doing, as well as the interaction with the National Institutes of Health, and then the public interface, which includes the interactions with the pharmaceutical industry. So what have they done today? Well, there's more than 200 diseases that are being studied. There's more than 400 active sites in 20 countries. Greater than 40,000 people now have been enrolled in these studies since its inception. They've trained over 250 people to work in rare disease research. There's over 3,500 consortium members and greater than 140 advocacy groups that have been involved. This monster is the network as it exists today, and there are 22 separate consortiums. When I first started, I think we had 9. If you look on here, they all are doing different diseases. There's the Brittle Bone Disorders Consortium, a chronic graft disease versus host consortium. If you look in the lower left starred, you'll see the CReATe consortium there studying motor neuron diseases. And just the flow on this picture emphasizes the nature of those common infrastructure elements that all of these consortiums can use. I want to switch gears now and talk more specifically about CReATe and what the mission of CReATe is and what some of the studies that we're doing are. But before I can do that, I really have to give some credit where credit's due. Michael Benatar, this was really an act of love for him. This was a major undertaking to get this consortium put together, to get all these different academic institutions to agree to do a common study. Is a little like herding cats, but he's becoming good at that. He's also tireless in reaching out to other collaborators in different areas around the world that have interests that correspond with the studies that we're doing. Joanne Wu, who works at his site as an investigator and really does a lot of great work with the data management. They have a project manager, Sumaira Hussain. If any of you interact with our study or decide to join it, you may talk to her, and she's been tireless in her efforts. And we have a whole team designed to help us handle biological samples that we get from individuals. So that's all and good, but what's CReATe? Well, like I said, it's physicians and scientists with a common interest in studying motor neuron disorders. This is just a diagram that I often show our residents or medical students when I'm first telling them about motor neuron diseases, and it just emphasizes the spectrum of different diseases that we see. All the way over on your right, you can see those upper motor neuron diseases. This is the stiffness and spasticity. HSP and PLS fall in that category. All the way over on the left are people who just have the spinal motor diseases where you get wasting of the muscles and the twitching, and that's a disease like progressive muscular atrophy. And ALS sits right in the center, and you can see there's both sporadic, meaning we don't know why people get these diseases, and inherited, meaning you inherit a mutation. And what is CReATe covering? Well, it's really covering all of those diseases with the exception of spinal muscular atrophy. So the overarching goal of CReATe is to get a better understanding of the clinically, what happens to people over time? What is the pattern of the involvement in their body? What's the relationship of what we see clinically to the genotype for those who have mutations? It's to develop biomarkers and to create tools to help facilitate us in drug discovery. And ultimately, that's the overall goal of the network, to help hasten therapeutic development for these disorders. Well, it is a consortium, and so just like that network, there are complicated flow diagrams, and this is the one that represents CReATe. All the way on the far left, you can see that's the head of that octopus I talked about. That's all that infrastructure support that the Rare Disease Network is providing. We have a lot of different groups who do different things. We have an administrative group who helps us coordinate all the different studies that we're doing and how we do them. We have all the sites that are involved. We have people who their whole job is just working on the genetics. We have people who work on biomarkers. These are things you can measure in your fluids, like your blood or your urine, that might give us an indication of what's going on with HSP or PLS. We have a training program and an outreach group as well. These are the studies that are currently active in the CReATe consortium. I really want you to pay attention to that first one, because that's the workhorse. That phenotype, genotype, biomarker study, this is what's driving all the others. This is the largest one. It's looking at what happens to people clinically over time. It's genetically characterizing these people. It's collecting these samples. And now we've added on another piece where we're looking for evidence of environmental exposures to what's happening to them clinically. The second one is kind of fascinating. How many of you, when you go to see your doctor, are they using an electronic medical record? Probably most of you today, because most clinics are starting to do that. And you may have wondered, well, they're doing all this stuff in an electronic medical record. Why can't they just use that for research? And there's really no reason we couldn't, because all an electronic medical record is a database. But what keeps us from doing it is everyone's collecting things in different ways at different sites. So this protocol is really designing common forms for motor neuron diseases that we can roll out at all these sites, so that information we're capturing in the clinic can help us understand what's going on in people over time. That third protocol is one designed to run completely on the registry. So if you can't come in for a visit to one of our sites, you can still participate in the meaningful research by just joining the registry. And we're trying to see what happens to people over a year by having them fill out questionnaires. 2 of the studies are based at looking at biomarkers, and I just want to point out that last one because it's also kind of novel and interesting. It's using your smartphone, and I'm guessing that most of you have one of these, and the things that are built into it that help track your motion and how you move, as well as to ask people questions to help get a better understanding of the disease. This is the network as it exists today. You can see in Florida, those are the 2 coordinating sites for data and for everything we do. Each of those red sites is an active site where we're recruiting patients right now. Those orange ones are sites that are about to become active. Indeed, the Twin Cities and Stanford have just now become active. And you can see we've now spread out to 2 other countries as well. There's a number of core units that are part of CReATe who have a role independent of these studies. we have a group that all they do are handle all these biological samples, the blood, the serum, the urine, the cerebral spinal fluid. They're making sure it's all kept properly. This is to help us with the particular studies we're doing in CReATe, but there's really a major goal here to make these broadly available to the whole scientific community so we can really hasten therapeutic development. We also have a group of people where all they do is the genetics. They do the actual testing, and then we have groups who are meeting to discuss the results of this genetic testing and make sure we understand what we have. We have people who are doing the ALS genes and the HSP genes, and then the results are returned. This is just an example of some of the common genetic genes that we're actually including in our first run of testing. We're also looking for new genes in a more experimental way. As you may have noticed on my very first slide, there are a lot of people who have been helping us with the work we're doing, including the SPF, which has been tremendous in helping us get people involved. Each of these organizations have slightly different roles. EPIC is a medical record person, and they're helping us with those forms. Avenir is a drug company, and they're helping us support young trainees. And so there's a really broad and growing group of partners that are working with us. One of the major goals of a network like this is to train the next generation. So when those great physicians like Dr. Fink, as they get older, will have the new young physicians to come in and start doing the work. You can see that I'm one of them, but our two young scholars who are working now are both working on biomarker projects. In addition to training people, we also provide funds in an open fashion for people who may have intriguing new ideas that just need a little money to get started. You can see a list of these projects right here. The first three are really related to biomarkers, things that we can measure in the blood or body fluid and follow over time. That second one from the bottom that's called dried blood spots is kind of fascinating because it's actually funding someone who's looking at the physical characteristics of an easy way to get blood from people from home. You just prick your finger, get a drop of blood, and you put it on a piece of paper and you mail it in. If we could do this, it could greatly reduce the burden of collecting these kinds of things from people. And this person's figuring out the physics of how you do it. And we even have someone who's just translating some of the tools we use so we can increase our outreach to include people who speak other languages. As I mentioned, advocacy and outreach is a major part of what we do. There's the website, as I mentioned. This is the link for the registry. The registry is open to anyone. You can Google RDCRN, HSP, and registry and get to it. We have studies that are running where we'll query people on the registry, and you would be notified for any upcoming studies. There's also a virtual environment where they have educational webinars or journal club. I want to spend the remainder of my time now diving a little deeper into the specific projects that are going on now that you all could volunteer for. The workhorse, the major protocol is this one. This is the one that we're bringing people in and we're learning about disease and how things change over time. It's a longitudinal study, which means we'll have people come in for multiple visits. We have people come in every 6 months for 2 years. Then we do an annual phone call to find out what's changing for individuals for as long as they're willing to do it. The inclusion criteria to be in this study is quite broad. All you really need is a clinical diagnosis or a strong clinical suspicion from your treating doctor that you have one of these disorders, and you have to be able to come to one of these centers where we're doing the study. We also are including family members in a somewhat limited sense to help us better understand the genetic mutations that we're seeing. We were hoping to get 500 people who will have a disease who we don't know why they get it, and another 200 who will likely end up having genetic mutations. This is just a pictorial overview of the study. You can see it looks pretty simple when each of these diseases is just a little circle, but of course, as we've heard, HSP now, there's a growing list of mutations. It's well now over 60. ALS is the same way, and so there's really a tremendous amount of diversity in this population. It's just showing that the heart of the study is you come in and you go through these longitudinal evaluations. At the same time, we would be collecting these biological samples, which are an amazing tool because we know so much clinically about the people who've given them. And then we do the genetic testings, which we will return to individuals who've participated in the study. So what are we looking at? Well, I've mentioned some of it. We're looking at blood, we're looking at urine and CSF, we're doing the genetic testing. We take a pretty detailed history. This includes a detailed symptom history, a family pedigree, your other medical conditions or medications that you're taking. We do a detailed physical exam. How many of you have actually come in for one of these visits to one of the CReATe sites? So not as many as I would hope, but maybe more of you will. You can talk to them about it. That first time we do the exam, it takes a while because we're really going through in a detailed way to look for those signs of spasticity, our upper motor neuron signs and the lower motor neuron signs from the head all the way down to the toe. We're using some standardized functional assessments, and we're using a cognitive screening test known as the Edinburgh Cognitive and Behavioral Screen. This tests things like your executive memory, your language, your recall, your visuospatial memory, and depending on how people do on that, it may trigger more testing. This is just an example of what are the kinds of things you would see if you did a screening test like that Edinburgh Cognitive Assessment. It might have you name objects. It might give you a descriptor and have you point to a picture. It might ask you to look at something that's visual like this, stacked cubes, and be able to interpret how many you see in these different configurations. For the functional assessments, we're using two well-characterized standardized functional scales, the ALS-FRS. This was designed for ALS, but it's really just a fundamental functional activity scale. The things it's measuring are necessary to life: speech, swallowing, using your hands, using your legs, and breathing. Each is scored from 4, meaning you have no involvement, to 0, meaning you can't do it or it's significantly impacting your life. So the way this scale works is it starts at 48 and it goes down to 0, which would be a severely affected individual. This is an example of one of the questions. So not only can you follow the score over time to see how people are changing, you can use it to see if someone didn't have problems speaking at the beginning, did they develop it over the course of the study? And that helps us get at this notion of what's the risk of something occurring over time, which is quite important. You could also do the same thing for the ability to walk. This is not from our study, but it's just showing how you can follow this over time to see the disease progressing. It has the score on that ALS-FRS-R on the y-axis, time of follow-up on the x-axis. You can see some individuals have a very rapid disease where they progress quite quickly, and unfortunately many of those individuals will then die. And you can see some individuals, though, are quite stable and are progressing slower over time, and this might be more consistent with what we see in PLS. For PLS and HSP specifically, we're using something known as the Spastic Paraplegia Rating Scale. Again, a scale that's looking at fundamental and important activities of what you do. This is evaluator or investigator administered, meaning it does have some measurements involved, but it's things like climbing stairs, walking, getting out of a chair, the contractures, which is how stiff you are around a joint, our pain and bladder function, as well as an inventory for those of you with HSP who have those other complicating things, either cognitive involvement or neuropathies. Each is scored from 0, meaning no involvement, up to 4, meaning significant involvement or you can't do it. So it's just the opposite in the way it scores than the ALS-FRS. That's an example of one of the questions. The scale goes from 0 to 52. And again, this is historical data from the development of the scale, just showing you on the y-axis that number on the scale and on the x-axis, how long you've had the disease, are related. So where are we at to date? Well, this was as of March 2017 in our recruitment. And what you can see is there was a little bit of a delay as all the organizational structures got in place. But over the last year, there's been a rapid uptick in our enrollment. If we want to look more specifically, though, about which of these different diseases are coming into the study, what you see here are our major disease categories: ALS, progressive muscular atrophy, PLS, and HSP. The first column is what we predicted we would see before we ran the study. Those percentages were based just on the percentage we thought of people who had these different disorders. You can see our actual enrollment to date has matched that early prediction pretty well, with one exception, which is we've done better than expected for PLS and HSP, and a lot of this is due, I think, to getting the word out from the SPF, and we're really grateful for that, and we encourage, if you know anyone who wants to be enrolled, to contact us. So where are people going to see? Well, it turns out for HSP, the two main centers have been the University of Kansas and Iowa in the Midwest, although this might be a little deceptive because I know at my center, at least half of these individuals have come from other states. When we look at the baseline characteristics of the people who've already entered the study, you can see a few things. Unlike ALS, where we typically see more men than women, you can see we're actually seeing slightly more women entering the study here than men for both of these disorders. And the average age of people who are participating, you can see they're somewhat similar. The HSP is a little bit younger, but if you look at the range of ages, you can see the differences between these two diseases, where PLS is commonly a disease that starts in the 4th or 5th decade, but in HSP you can see there's that full range from very young to very old. The average amount of time that people have had the diseases is longer for HSP, which fits with an inherited disorder that some individuals will have very young. In terms of family history, I don't think there's any surprises here in the fact that PLS doesn't have any, because of course part of how we give you a diagnosis as PLS is that we don't see that family history. We've had about 44% of the HSP people who've entered our study right now have a known family history. If you look at those functional rating scales to see how people are doing in terms of their function, that number 20 is a little hard to interpret, but the original study that had developed the scale, that was the average they saw in a large group of HSP patients. I would say this would represent moderately affected individuals, but you can see there's a fairly broad array of functional disability. If you look at the ALS-FRS, you can see it's maybe not as good a scale as the other one because most of the people are up towards the top or the more normal range of that scale. But still, for this measurement, for both diseases, you can see there's really a pretty good range of functional impairment that's entering the study. When we ask individuals where did they first have symptoms when the disease started, and they could check as many of these different regions as they thought applied to them, I don't think there's any real surprise that almost everyone with HSP said their legs were involved early. I think it's interesting that speech and swallowing, 10% of the people said they had that. For PLS, I think this is more consistent with what we already know of the disease. A majority of people have problems in their legs, but over a third of people can start with symptoms in their speech or their swallowing. All of these individuals are giving these biological samples, but what's unique about this study is we're getting them at every visit. This will be an amazing resource for research. Could you imagine if you had a new drug and you thought there was something you could measure in your blood, but you said, we need a way to validate it, to show that it's going to work. To have this data available will greatly streamline that process. And I want to spend the last few minutes, and I'll try to be quick here, just talking about a study that we're running on the registry. So this would be for those of you who couldn't get into a center to be in a visit, but wanted to take part anyway. This study was to determine the feasibility and the ability to use a patient-reported outcome of function that's a variation of that ALS functional rating scale with some additional questions about things like bouts of laughter or crying in pain. We want to see if there's anything that people report in a questionnaire at the beginning that might predict how they do over time, and we're going to compare this to previously reported progression models. Well, why does this matter? If we have a good tool for modeling how things change over time, you could imagine we could do a very large study where we could help people understand how things like exercise or taking vitamins or supplements might affect the way their disease is progressing. To get into it, well, you just have to be in the registry and self-report that you have one of these disorders. You have to be able to fill out the questionnaire. Unfortunately, right now, it's only in English. We try not to be too invasive. It's all done electronically. You would get an announcement of the study, and then we're asking people to fill out these surveys once a month for a year. So these are the people in the registry, and I think it's worth pointing out because there's 142 HSP people who've already signed up for the registry, which I think is excellent, and 68 people with PLS. For this study, so far, we've had 35% of eligible people have decided to participate. I'm hoping we can get that up to 40% over the next 6 months or so. When we look at the characteristics of these people, I think now you see that there's a stronger evidence for that division in the age with the HSP participants a little bit younger. There's more women, and you can see in the racial breakdown, this may have something to do with who decides to join the registry, because sometimes one kind of person is more likely to do it than other. So I think women have been more likely to join the registry, which is great. And then finally, I do want to finish showing this because I think it's fantastic. When we ask people, how did they hear that this registry exists? You can see there's all sorts of ways. They could search the internet or look on Facebook, but for both HSP and PLS, the #1 answer is that they heard about it from a support group. So we want to thank the SPF for this. And I want to end with just a couple thoughts about future directions. We're still enrolling. This is our main project manager. If you want to be in the study, you can contact her and she'll direct you to the main site. If you can't get this information now, I'll provide it to the SPF and they can distribute it to people later. We're forming study groups for each of these different outcomes and things that we've talked about to analyze them in really intense detail to understand them. And we're committed to leveraging the infrastructure and all the training that we're doing for all these sites to support clinical trials. As evidence of this, we have 2 possible collaborations that are set to start with our counterpart in Europe, which is known as CReATe. These are studies designed to repurpose existing drugs to use for diseases like ALS. We have a pilot study of a supplement that's thought to be protective against oxidative stress and mitochondria that's getting set to start for ALS, but might be applicable for other motor neuron diseases. and we're really interested in finding future studies for HSP and PLS. And finally, I'm just going to thank all the people who've participated, and I just have to show you there are a tremendous number of people who have important roles in making this happen. Samara, who I gave you her information for, is in the top left. You may be seeing her or interacting with her. The cartoon figure 2 slots below her, Joanne, helped me a lot getting the information for this. You can see Michael Benatar right there in the middle. And then each of those clinical sites activated is a little deceptive because they represent a staff of 10, 15, sometimes 20 people who are working on research at their site. All right, thank you very much.